Yeah, sorry. So actually, I was on mute. Uh, Sorry for that. Good evening, everyone. Could you please confirm whether am I audible or not?
Yes, sir.
Yeah, thanks. Thanks a lot. So let us start. So in last lecture, we discussed about connection of uh, voltmeter, ammeter. In what way should we connect so that we can get minimum error? So we saw two cases: a meter before voltmeter or a meter after voltmeter. So first configuration was a meter after voltmeter. In this case, we concluded that when load resistance is much higher than a meter resistance, in that case, you are going to get least error in configuration 1 when a meter will be placed beside voltmeter or after voltmeter. In second case, we saw in configuration 2, we saw that when voltmeter resistance is much higher than the load resistance, in that case, you are going to get least error, right? So we have to keep in mind, and we also discussed why is this happening, because in first case, voltmeter reading was not exact the reading of the voltage across the load, right? It was the sum up of a meter, a meter voltage drop across a meter and voltage drop across the load. So we saw that in overall error, if a meter resistance is low, in that case, we are going to get least error. So percentage error was RA by RX into 100%, right? So we can tune RA so that it should be low, and when it is low, we can connect as a configuration 1. And as a configuration 2, we saw that a meter current is also flowing to across the voltmeter resistance as well as the load resistance. So in that case, if you keep, like, finally we concluded that error was coming out to be Rx divided by Rb plus Rx, and in that case, if you maintain the value of voltmeter resistance as high as possible, then you are going to get the minimum error. So I hope it was fine. Any question from the last lecture? If not, then let's move toward the.
No, sir.
Okay, great, thanks. So let's move towards the new topic. So today we will discuss, bridges, Wheatstone bridges, as well as electrodynamic instrument. So why is it called electrodynamic instrument? Because it measures the time varying parameters. Because your current could be AC and it varies with time, and as well as your voltage could be AC or DC. And when it is AC, because we are ultimately with electrodynamometer, we are going to calculate our output power of the instrument, and output power is sometimes instantaneous. It depends on the which instant you are going to calculate. So let us see and move forward. Okay. So first, a couple of questions from the last week which were left out. So let us solve, and then we can move forward. So we did not discuss any problems based on PMMC instruments. So how to use PMMC instrument and for what purpose? Because as we all know that PMMC instrument, it shows us the DC value, but we can measure AC parameters as well with the help of PMMC instruments. It's just that we have to calibrate it in such a manner so that whatever is coming out or whatever we want, it should multiply or calibrate in certain fashion so that it will give you exact value. Okay. So the question is, a voltmeter is prepared with a PMMC instrument. Okay, you might have also solved this problem for assignment 2, I guess. Yeah, so in assignment 2, I hope you must have submitted this problem. So let us discuss it anyway, in case for your final examination, you should have this concept very well in your mind. So as we all know that a voltmeter has a series resistance. So voltmeter parameter I am going to write. voltmeter full scale deflection is what 10 volt DC voltage, right? Because voltmeter can measure the DC value. Now, while measuring an AC voltage with this same voltmeter, we have to measure AC voltage. It shows 40% deflection. Okay. And frequency of the AC voltage is also mentioned. It is frequency is given as 65. Okay. Now we need to find out the amplitude of this AC voltage if the AC voltage is perfectly square. So the AC voltage is a square waveform. Okay. And this kind of voltage we need to calculate using a PMMC instrument. Okay. And this PMMC instrument shows 40% deflection and its frequency is given 60 Hz, right? So how to find out this value, its amplitude, okay, this value. Okay. So we all know that PMMC instrument measures the average voltage, right? And its rating is given full scale deflection, or rating you can say 10 volt. So 40% deflection means it will be 40% of FSD. It means 40% of 10 volt, right? So it is going to be 4 volt, isn't it? So 4 volt we are going to get at 40% deflection. Now, and this 4 volt is what we don't know. But we need to find out the amplitude of this waveform. So how to move forward? So basically, let us move one step at a time. So what essentially PMMC will do, PMMC will have a half wave rectification, right? And once it rectifies, this waveform will be like this. And remember, PMMC will provide you the average value. Okay. So this kind of waveform, this PMMC will give you. Okay. Now I think we can calculate average value of this waveform. We need to calculate average value of this waveform. And that will be equal to how much? It will be equal to 4 volt, whatever is deflection being shown on the instrument. Okay. So average of this square wave is how much? Half into A into this will be T by 2. It will be T. T is nothing but time period. T by 2 divided by total time period. Isn't it? Oh, sorry, half. It should not be half. Half generally comes in triangular waveform. It is rectangle. So rectangle area is area divided by time period. So area is A into T by 2 divided by time period. So it will be A by 2 is equal to how much? 4 volt. So how much will be the amplitude? It is 8 volts. So 8 volt is the answer for this problem. Any doubt? So I hope you got the idea how to calculate, amplitude or PMMC. What does it give? Right? It shows the value of average. So if average is known, right? So that it is very interesting question. So if we have an AC waveform, so we are generally not concerned with average. We are concerned with RMS value, isn't it? So what will be RMS value? Because generally in any machine or anywhere, if you see any AC quantity, its RMS will be the rating, right? 230 volt, 50 hertz, like that. In such fashion, 230 volt, 50 hertz kind of ratings you might have seen in several problems or several instruments or several, any electric appliances you might purchase. You can see this kind of rating. So we are concerned with RMS value. So what will be RMS of this waveform?
रूट
Square root of,
अंडर रूट होगा
please.
सर, और इंटीग्रेशन 0 to पाई होगा.
Exactly. So you are correct. So can you just see this waveform and let me know the value? So for this kind of waveform of voltage, what will be the RMS of this kind of
एच बाई रूट 2 होगा सर.
A by root 2?
यस सर.
Okay. So let us calculate. Okay. So VRMS is equal to 1 by T. Okay. 0 to T A square dt. Isn't it? So see, 0 to T, this is T by 2, this is T. So if we further break it down, 0 to T by 2, A is nothing but A square into dt. Okay, plus T by 2 to T is minus A. So A square we can take it out, right? And dt will be T by 2 plus T minus T by 2. So this will cancel out and we have what? Under root A square by T into T, which will be equal to A. So RMS value is A. Okay, I hope you got it. Now, if the RMS value is A, its peak value is also A. So that's very important in a square wave voltage, right? Okay. So संगीता said that week 4 assignment का problem solving discuss करते तो अच्छा होता, कल ही last date का week 4 assessment submit करना. Okay, so we are going to discuss week 4 assignment. So any doubt, Niranjan? I don't think any doubt is here. Mm-hmm. Okay, so let us start problems from week 4 assignment. Okay, so let me write down. I'll start with 240 volt single phase induction type energy meter. Okay, it is designed to make 150 revolutions for every kilowatt hour of energy. So we can also rewrite it for 1 kilowatt hour of energy. Okay, energy kilowatt hour is the unit of energy. Okay, now calculate the expected number of revolutions. So number of revolutions we need to find out how much when it is connected to load of 30 amps 0.85 power factor for 2 hours. Okay, can we do that? So Niranjan, I hope it is fine. We are discussing week 4 assignment. Are you there? Okay, so first thing is to calculate energy is power in such kind of problems. We first calculate the power and then we can multiply with time and it will give us the energy. Okay, so and now we have revolutions per kilowatt energy, so we can reassign this value to get our answer. So first we will calculate power. Power is nothing but we can calculate VI into cos phi. That will be V into I into cos phi. So voltage is 240, current is 30, and cos phi is 0.85. So it will be, if we calculate, it will come out to be 6.12 kilowatt. Okay. Now it is running for 2 hours, so energy we can also calculate. So it will be 6.12 into 2, 12.2 kilowatt hour. Okay. Now it makes 150 revolutions for 1 kilowatt hour. So it's one to one problem. 150 kilowatt. Sorry, 150 revolutions for 1 kilowatt hour. So we have 12.2 kilowatt hours. How many revolutions we need to calculate? Okay, so it will be equal to 12.2 into 150. So how much it will come out to be? 1830, isn't it? Two 40 into 30 into 0.85. Okay, so I hope it is fine with you. Now, let's move towards the next problem. If meter actually rotates, how much? 75 revolutions. Okay, then in that case, we need to compute percentage error. How much? So to calculate the percentage error, we know percentage error as a percentage of actual energy consumed, right? So for that, we need to compute energy for 75 revolutions. So how much energy being consumed for 75 revolutions, that we need to find out. And then what we can do, we can do a measured minus true divided by true. That is the percentage error we can calculate. So energy consumed for 1775 revolutions are how much? 150 per kilowatt. So 75 divided by 150, it will come out to be 11.83 kilowatt hour. Okay. So this much kilowatt hour is actually consumed for 75 revolutions. But it is showing that it has consumed how much kilowatt hour? 12.2 kilowatt hours for 1830 revolutions. So what will be percentage error? Is measured it is how much? Measured is you know uh, 12.2 kilowatt hour. No, yeah, 12.2 kilowatt hour minus 11.183. It is actual divided by 11.83. So how much it will come out to be? It is 3.1%, 3.2% actually. So 3.2% of error is there. Did you get it, Niranjan?
Yes, yes.
Yeah. So instead of it, also you could have done the other way. You might not need to calculate the actual revolutions. You could have, sorry, actual energy. You could have straight away went ahead with how much is the measured revolution. So measured revolution is 1830. True or actual is 1775 divided by 1775. So this would have also given you the same value. So since we need in terms of energy, and that is why we went ahead with calculation of energy just to be sure. But energy is coming out of revolutions as well. So we had the value of revolutions, and we could have easily plugged in the equation, and we could have got it. Okay. Now the thing is, we should be very much clear about the definition of errors, right? So in week 3 lectures also, you might have gone through the definition of errors. So I hope there is no any doubt on this problem. Okay. So there are two most importantly and most vastly used terms of error related to error. One is absolute error and other is relative error. So absolute is very straightforward. How much is the true value and how much is the measured value? Okay. And relative error is nothing but absolute error you definitely need to calculate. Okay. Absolute error you will have to calculate and you have to divide it by true value, which what just we did, right? We just did this value. Sorry, we just did this calculation, relative error. Relative error is also known as percentage error. So in this problem, it was asked that if meter actually rotates this time, then we need to find out the percentage error. So percentage error is nothing but absolute error divided by true value. Okay. Okay, let us move ahead. Now we solved these both problems, and we have to find out that whatever we calculated, okay, whatever the measured energy is, whether that is less than the true value or actual energy, or whether that is higher than the actual energy. So let me write it. So we have to tell whether measured energy is higher than the actual or true, or is it less than the actual energy? What do you say? We just calculated both parts, right? So for that, you need to compute energy corresponding to, 1775 revolutions. So we measured 1830 revolutions. Okay, we measured it 1830 revolutions, but actually it rotates for 1775 revolutions. So whatever we are measuring, that is showing more revolutions for same amount of energy, right? So in that case, the energy measured is less than the actual energy. Okay, so this was the measured energy, 12.2 kilowatt hours. We also calculated, and for actual energy would have been consumed, that is 11.83 kilowatt hour. So measured energy is definitely 1830. Sorry, 1830. No, 12.2 kilowatt hour. This 12.2 kilowatt hour is the measured. It is measured, which is, and the actual is 11.83 kilowatt. This is actual. So measured is higher than actual. So this is how you could solve the other problems. So I hope you must be getting the same problem in the current week assignment also. So please take care of this. Okay. Any doubt in this whole problem? There were three parts in this. Okay, great. Thanks. So let us move ahead to the further next problem, which is very interesting. Okay. So problem number 2. We have one ammeter and we have one impedance. Sorry, let us not denote it with the distance. We have one impedance. Now another ammeter is connected parallel to A1, which is A2, and it is connected with, in this branch, one resistance is present. One last branch has third ammeter in connection with one resistance and one AC source. Now we have reading ammeter 1 reads 5.75 ampere, ammeter 2 reads 3.25 ampere, and ammeter 3 reads 8.25 ampere. Okay, and this R is given as 700 ohms. All ammeters are ideal. It does imply that they have very low internal impedance. Now we need to find out the magnitude of Z. Can we find it out? Please suggest some way to find it out. Any idea? What will be the value of impedance or how to calculate it?
और कुछ वैल्यू दिया हुआ है
सब दिया हुआ है A2 का दिया हुआ है, R दिया
निकल
हुआ
जाएगा
है
सर वोल्टेज
हाँ
ये दोनों का वोल्टेज तो सेम ही होगा सर
ओके यस एग्जैक्टली ये दोनों का वोल्टेज सेम होगा so whatever voltage we are going to get here the same voltage will be here so what is that V is equal to this 3.25 into 700 right oh sorry 3.25 into 700 3.25 into 700 it will be let me calculate 3.25 into 700 so it is 2275 volt okay अगर ये voltage दिया है then we can also calculate this Z right this V is equal to 5.75 into mod of Z okay mind it it's amplitude of impedance okay now amplitude of impedance is 2275 divided by 5.75 it is equal to 5.75 it is equal to how much 395.7 okay so we don't know about the character of Z whether it is resistive reactive you know or combination of both we don't know yet okay so we calculated the magnitude of Z now the second part of this problem is how much is the power consumed by impedance Z so we need to find out power consumed by let us not denote it with plus minus we need to find out the power consumed by Z
I square R
I square R exactly I square R but do we know R do we know the value of R and we do not even know whether it is inductive or capacitive or combination of resistance inductance or resistance capacitance or combination of everything so what to do now but we do know the magnitude of this current A3. So can we do something? Okay. So now you will have to recollect the concept of vector. So when we used to have two vectors, A1, A2. Okay. Vector can be, a scalar, but a scalar couldn't be equal to vector, right? So what I am trying to interpret here that if you just if you can call a scalar as a vector with directionless, but you cannot call a scalar quantity as a vector. Okay, so a1 a2, right? So let a1 a2 I am writing as a ammeter 1 and ammeter 2. It is better we write I1 and I2. So since we are in electrical engineering, we need phasors similar to vector. Okay, so I1 I2. Okay, and in electrical we do not use this arrow. We just put a bar, and when we needed to calculate a resultant vector, I resultant, what we used to do?
Vector sum. Vector something
Vector
in the
sum,
graph.
exactly, very good. And which will be equal to how much?
I
I1
square
square
plus I2
plus
square
I2
plus I2
2
divided into
I1
cos angle of
I2 cos theta,
cos
exactly. Great. And this theta is nothing but the angle between
I1 and I2.
I1 and
I1
I2.
and
Okay. Now I think we can easily solve it because we are given with A3, means current is flowing in this direction, which is resultant, right? Nothing but I3 is nothing but I1 plus I2, isn't it? So can you now solve it and let me know the answer of power? Okay, first, just let me know the resultant or resultant current we know. Let me know the power consumed by the impedance Z. So I am also solving here parallelly. Okay, you can also solve on your own. So now we got it. So I am just going to put the value, and I resultant means magnitude. So it is nothing but 8.25. Okay, is equal to I1 square, which was 5.75 square, plus I2 square, which is nothing but 3.25 square, plus 2 into 5.75 into 3.25. Now, into cos theta. Okay. So I think we can calculate what? Theta from here, isn't it?
yes.
Yeah. So could you please let me know the value of theta? Okay, I am simplifying it one step more. Cos theta is equal to 8.25 square minus 5.75 square minus 3.25 square divided by 2 into 5.75 into 3.25. Now I think we can calculate. numerator part I got, you also match it on your side. So 375. Okay. Now denominator side is 2 into 5 point. It is 37.375. So how much did you get it? I hope these are correct.
कैलकुलेटर अभी मेरे पास नहीं है सर, बहुत प्रॉब्लम।
Okay. So I'm calculating it. 24.4375 divided by, so it is coming out to be 0.6538. This is cos theta. Okay, now we can also calculate theta, which is cos inverse of 0.6538. Okay, so cos inverse of it. It is 49.17 degrees. Okay, so we calculated cos theta. Okay, now we need to power consumed by this impedance. Okay, so the angle between I1 and I2 we calculated, and since we know that I1 is purely, sorry, I2 is purely resistive current, this current is purely resistive. So if we could anyhow compute the power, consumed by this impedance Z in terms of whatever the value of this phasor, or whatever the voltage drop is happening to the Z. So we need to find out basically this Vz and Iz and cos theta, isn't it? Iz we know. Let me rewrite it. P is equal to Vz, Iz, and cos theta. Okay. Now, cos theta we have calculated. Iz we have. Okay. Vz we do not have. So can we calculate it?
Yes sir.
How?
5.75 into 309 into 395 into 7.
Uh-huh. Okay. You are there.
And
And
the angle को into कर देंगे सर, cos theta निकला है।
yes. So that will be equal to, this Vz we can also call as, Iz is fixed, that is 5.75. Now, Vz will have two components. One is real plus imaginary, or J. Okay. What I am trying to interpret here, let me write real of Vz. It is better to write it as this, in this fashion. real of Vz
सर करंट कोई एंगल का फॉर्म में नहीं लिख सकते हैं।
of Vz. Okay.
करंट जो 5.75 आ रहा है उसमें एंगल लगा के हम ये निकाल नहीं सकते।
5.75 में एंगल लगा के निकाल सकते हैं, बट 5.75 में जो एंगल लगाएंगे वो होगा हाउ मच? देखो, I1 into cos theta will be equal to I2, right? Isn't it? But we want to know the angle difference between I1, this I1 and Vz, means V1 and I1, this V and I. You got it? We want this angle between Vz and Iz, not angle between I1 and I2. Both are not equal. Both may be equal, but both may not be equal, right? So to do that, what we can do here, that we just need to find out the real value of Vz. And the real value of Vz will be how much? It will be equal to this much. Because this real value of Vz will give you the value of 3.25 into 700, because the parallel branch, parallel to first branch, let me see, this is first branch which has real and imaginary. Second branch, it has real only. Third branch again has what? Real and imaginary. So we are sure that this branch has 700 into 3.25. That is purely real.
Yes.
Okay. And if you multiply it, that will be our Vz. So Vz will be nothing but 3.25 into 700. Okay. And it will come out to be
2275 sir.
2275 again. Yeah. I think I have calculated earlier. So 2275.
Yes, sir.
Yeah. So 2275. Okay. 2275, 2275. Both voltage are same. Okay. Now we know the angle. Okay. So we can do power also 2275 into 5.75 into cos theta. Okay. Why cos theta? And why this theta will be the same as this one into 0.6538? Let me explain it. Because this current component will have imaginary angle with A3. So A3 is resultant. So this is theta 3, you can say I1 and I3. This will be theta 3. Okay. So whatever is coming the angle between I1 and I2, the same angle will be equal to Vz and I1. Because, and if you want to calculate going to use this theta 3, it will be nothing but Vz and I3. Are you getting it, Niranjan?
और एक बार रिपीट कीजिए सर।
ओके, सो ये जो थीटा 3 होगा, ओके, वो होगा अपना ये वोल्टेज और करंट I3 के बीच का एंगल। क्यों? क्योंकि जो I2 है वो प्योरली रियल है, राइट? तो वहां पे तो कोई इमेजिनरी कंपोनेंट जा ही नहीं रहा है. No imaginary component is going towards the second branch, right? Okay.
ओके सर.
So it was a bit, conceptual question.
सर इसमें भूतकी भी तो बोल सकते थे ना सर, मतलब
V3, V3. This V is
या
same across all the branches.
yes.
Yeah, yeah. So I just dot Vz just to specify which voltage. Or this is only V. We could call it V also. Okay. Any last doubts on this problem? Okay. So this is how we will solve this kind of problem. Now we need to find out the power factor. Power factor is how much? Same, yes, we now calculated. We need to find out power factor. Hmm. Nothing but V into I1, power factor of Z. Okay, so power factor is nothing but cos theta, right? So this is, if this is R, this is, let's say, X. So this will be Z. So this will be power factor. So Z R is nothing but Z cos theta. Okay. Same happen with, you can also analogously write I2 I2. No, not in this fashion. No, this we cannot do. And this cos theta we have already calculated, isn't it? 0.653. So we have already calculated this part in the earlier problem. So it will be 0.653. Okay. Now moving forward to the next problem.
इंडक्टिव टाइप का ये लगा हुआ है ना सर?
Sorry, क्या लगा हुआ है?
इंडक्टिव.
Inductive, yes, inductive. If cos theta is, kind of this, it means it is inductive. अगर वो रहता, then theta should come out to be, negative. अगर theta is positive, it means inductive load. If theta, cos theta is negative, it means capacitive. है ना? Okay then. और हाँ, let me also draw the phasor of this entire circuit. Can you draw the phasor of this entire circuit? We know the current phasor. We can also draw the voltage phasor. Okay, I1 और I2 के बीच का एंगल आया था how much? Beta आया था 49.17. I1 and I2 के बीच का आया था 49.17. So can we draw the phasors for V1 and V2 now? V1 can I sorry V2 can I say this will be the phasor? Okay.
Yes.
V1 what to say?
Just
Lagging power factor.
below. Yes.
Yeah, just below V2 and above I1.
Yes, sir.
Isn't it? This one is V1. Okay. And apparently, what is the angle between I3 and I1? I3 and I1. I3 was the resultant. And the resultant angle, do we know? V and I3, no, we don't know. So I3 also must be lying somewhere here. We don't know whether it is lagging or leading. We have to calculate for that. Okay. But I3 must be lying somewhere there. Now, one thing is for sure in this circuit, see the circuit very carefully. It has source here. Okay, so the current must be going from this direction, isn't it? Current, current must be going from this. Okay, I3, I2, I1. This must have been the direction of this circuit. Okay, so I could this. Yeah. Now the circuit direction we know. Right. So I3 must be higher than I2 than I1. So it is possible to find out. So after this session, you just try to find out the angle between I3 and V3. Okay. Because such type of problems could be asked in exam. So it is important that you are very well versed with such kind of problems. In next lecture, we can discuss this and you let me know what is the value and we can also
Yes.
further discuss it. Okay. So this kind of solving the problem in the circuits where AC and DC quantities, resistance and impedance all are present, and you need to identify what kind of which. So that is very crucial for exam purpose. Okay. Now let us move towards the next problem. Next problem is based on potentiometer. Okay. So what does potentiometer do? It actually calculates the voltage, or basically it is you know variable voltage. You have one supply, but you want, let me draw it here. So you have this two contact terminals A and B. Okay, and across that you would have a supply A and B is denoting the full value of E. Okay, now what you can do, you can connect a wire from here, some kind of this. It is known as R test. This is actually problem of assignment 4. So we are discussing concept with this kind of problems. And here this G, and one contact is at J2. Okay, one contact is at J0 and one contact is at J1. Okay, so this is how it is connected. Resistance of this wire AB, RAB is given. How much? 20. Now supply voltage E is also given, that is 4.6 volt. Similarly, R test is also given, that is 11 ohm, and E test is also given as 1.3. Okay, and we need to calculate wire resistance on the left of the jockey. So basically, what we have to do, we need to calculate left of the jockey J2, isn't it? These three jockeys are present here, and we need to calculate this. So let me go through the basic first so that it would be easier to calculate it, isn't it? So basically, what do we have? We need one a standard source, and we could set the jockey at any position, okay, any position, and now we can adjust other one. So in lecture, if you might have gone in lecture, we had one a standard EMF and one EX, and we calibrated there. So phase when null is obtained with a standard cell in calibration phase, it was stated in the lecture. When null is obtained with a standard cell, no current was flowing through the cell, so there was no voltage drop. Okay, and if phase at null and no current flows through EX, so if I don't know whether you recall from the lecture or not, so this was the structure of the circuit. Let me draw. This was the E and this was R1, and one ammeter was connected, and I was going there. This is your wire AB, and this is how 1.58. Let me, yeah, so it was 1.08 or volt of E test. Just now we said, or the standard was mentioned in the lecture. Okay, and one EX was there, which was expected value. Okay, and it could be connected with a jockey at variable lengths. Okay, so it could be connected here, it could be connected here, or anywhere. And entire length was, this length of AB was 110 centimeter. Okay, now we will set the jockey at the example. In the example, the jockey was set at 50 centimeter. Okay, so if jockey is set at 50 centimeter, let us suppose this is 50 centimeter, okay, and this is 110. So this value of EX or E standard will be 1.08 into how much? 50. So it would come out to be 50 into 1.08. It came out to be 54. Okay, so this was the first step that you needed to calculate. Now, the next step was calibrate or adjust this R1 until you get a null value, right? So now voltage at 54 centimeter is the 1.08 0.08 value, and basically this was the standardization of the potentiometer, which I hope you might have gone through the lecture. So here in the problem, which is the null value, is mentioned in this problem. The wire resistance R we needed to calculate. So basically for this, what you could do, the wire resistance, the expression of wire resistance divided by test voltage is equal to the resistance of wire, sorry, the resistance of this total supply wire resistance divided by EMF source. So this is expression that you need to keep in mind, which will be able to solve the problem. So this is nothing but R, which R? This is this R, this jockey left hand side. So the resistance across this R. Okay, so this is the length of R. So R by E test divided by R by E source. Okay, so now we know that R is equal to capital R, which is 20 ohm, isn't it? Divided by E supply. E supply is how much? It is given 4.6 volt into how much is E test? Yeah. So E test is also given in this problem, 1.38 volt. Yeah. So it is given as 1.38. So how much this will be the value? 1.38. If you calculate it, you will get divided by 4.6. Nothing but I think 6. So R value will be 6, isn't it? So this was the value of R. So if you are calculating, so we have a fixed source. The purpose of what I was trying to convey here, the purpose of a potentiometer is to, we have a fixed source, generally any supply, and if you want to get variable voltage from that supply, so you could tune the value of R test, E test, or this R, so that you could get whatever the required value of voltage you want to get. Okay. Now, and this was the null position, isn't it? J2 was the null position. In second part, it is being said that if jockey is moved rightward through a distance corresponding to 1 ohm from the null position, then we need to find the test cell current. Okay. So test cell current is what? This current. I test. Okay. So in this part, Niranjan, do you have doubt in part first? We are moving to part 2 of this problem. In calculation of this R, do you have any question?
वॉइस थोड़ा सा कम आ रहा है.
फर्स्ट पार्ट क्या आ रहा है?
वॉइस सर आवाज थोड़ा सा कम आ रहा है.
कम आ रहा है क्या अभी? नाउ इज इट बेटर?
हाँ ये
Okay, just. I hope now it should be proper, right?
ओके सर।
Yeah. Okay. So first part में I think is there any problem in first part, because we are moving to second part.
नो सर।
We are going to calculate the test cell current. Okay. This I test. We calculated R. Okay. And R is nothing but 6 ohm. So it could have been in terms of length also, isn't it? Because the distance of RAB is 20. That is why we calculated the distance of this R. The length of R also could be calculated if the length of AB is given. So is the length of AV provided in the problem? Let me see. So no, length of AB is not given. So we have to deal in terms of resistance. Okay, because we standardize the resistance of AB and we are going to calculate related to or relative to that value. So we have calculated R. Now what is being said in part 2 of this problem? Oh, sorry, not two. Yeah. So in part 2 of this problem, it is being said that if jockey is moved, one jockey moved to the distance, and the distance is being provided in terms of resistance, move to the distance corresponding to 1 ohm resistance from null position. So null position resistance, we got to know how much was it? It was 6 ohm. Okay, so 6 ohm is the null position resistance. Now the jockey is moved 1 ohm forward to that. So now at this position, the resistance will be how much? At this position, the resistance will be R plus 1 ohm, isn't it? Which will be equal to 7 ohm. Now we need to find out the test current, okay, or test cell current. So can we do that? Can we calculate test cell current now? It has moved to this position, let's say R plus 1. So let me copy it. Okay, so now this is nothing. This is also not. Let us assume only the important thing here. J2 also will be removed. Yeah. So now this distance is corresponding to R plus 1 ohm resistance, which is nothing but 7. Okay. we need to calculate current test cell current. For that, what do we need to do? We need to find out voltage. Okay, so how much is the voltage there for this position, for this R plus 1? Can we calculate voltage for R plus 1? Ohm, R plus 1 ohm resistance?
1.38.
V of R plus 1 is equal to E into R plus 1 divided by how much? It was 20, right? So it will be 4.6 into 7 by 20. It will be equal to 4.6 into 7 divided by 20. So it is 1.61. 1.61 volt is the voltage here. So if we know this voltage, and the polarity of this voltage will be like that, isn't it? Because the supply polarity is like that. Okay. So this, sorry sir, sorry Niranjan, what are you saying?
कैसे किया सर? VR1
हाँ,
R plus 1
yeah.
equal to
डिवीजन, वोल्टेज डिवीजन रूल डू यू नो? लाइक यहाँ का
ठीक है
वोल्टेज पता है,
तो
ई पता है,
हाँ
और so let us consider it like this. So I am drawing an equivalent circuit. We have this voltage, okay, and we have this resistance, okay, and we have like,
ये तो ठीक
wait
है
a
सर,
minute.
इतना तो हम जानते हैं। तो
हाँ
ऑपोजिट रेजिस्टेंस लेना पड़ता है ना सर, जिस
हाँ
ये का तो जिस रेजिस्टेंस का वोल्टेज निकालना रहता है तो उसका ऑपोजिट वाला लेना पड़ता है और बाय इक्विवेलेंट किया जाता है।
अच्छा अच्छा, so that's what, okay okay, yeah, I got your problem. So what you are saying ki we also need some resistance here, right? So actually in potentiometer the total wire resistance is 20 ohm. The R of AB is 20 ohm, and
अच्छा
R
ठीक
plus
ठीक
1
है।
is equal to 7. So just like we are taking ratio, so 20 corresponding to 1 by 1, 20 corresponding to 4.6. So what does 7 will lead to? Just like that.
ठीक
Okay? So if you just take 20 by 7 is equal to 4.6 by x. So this is how we are calculating x, which is 1.61 volt. Now we calculated this voltage V across R plus 1. Now we need to calculate what do we need to I test, this I test. So this polarity also will be similar to this supply polarity, and voltage we know 1.61. So what can we do? And this E test also was given in the problem. I think I erased it accidentally. 1.38. No, it is there. 1.38. So now I test will be equal to E test minus 1.38 minus 1.61 divided by 11 plus R plus 1, 7. Okay. So this will be RTH. No, this will not be RTH. This will be direct your current. So how much it will come out to be? (1.61) minus 1.38, 0.23 divided by 18. Okay, so this will not give you RTH. So RTH we can also calculate by other way. because VTH, we cannot just straightforward do it like this. So we have this equivalent circuit. Let me draw this. So the polarity is like this, VTH. Now we need to calculate RTH, and it is across this value, isn't it? And one parallel R plus 1. So I have drawn an equivalent circuit to find out RTH. So RTH will be seen across this. Okay. Did you get it, Niranjan? This part? Yeah.
Yes.
Now we need to calculate RTH. So what will be RTH? Parallel में. So R plus 1 parallel with this R. Yeah, this R test. Isn't
Yes.
it? R plus 1 divided by this parallel with R test. All one thing are we leaving here? Any other branches would be considered here? I think we took all of them. R plus 1 is parallel with R test. R test is 11. Okay. So anything else is required? Yeah. Okay. So R plus 1 is 7 into R test is 11 divided by 11 plus 7. So 77 by 15, which would come out to be 4.3. 4.3 ohm will be your RTH. And now we can calculate I test. Okay. I test will be how much? I test will be equal to this E test minus VTH. Okay. E test minus VTH divided by R test plus RTH. Okay. Are you following, Niranjan?
Yes.
Yeah. So R test is E test is 11 minus VTH we have calculated here 1.61. Okay. So 11. What was the E test is 1.38 minus VTH is 1.61. R test is 11 and RTH is 4.3 plus 4.3. So if you calculate, you will get the value of test cell current. So how much is it? 1.3. It will come out to be negative. That is means for sure the current will flow in opposite direction. Current will flow in this direction. Okay. So please calculate this value for me. 1.38 minus 1.61. divided by 11 plus 4.3. So it is minus 15 milliampere. So it is equal to minus 15 milliampere. I hope you will get the same value. Okay. So the next part is, this is we moved one right from the null position of distance corresponding to 1 ohm. Now in next part, we need to move left of null position corresponding to 1 ohm. Okay. So now we will again do the same thing. Okay. We will have to find out R minus 1 this time. So R minus 1 is the new value, which will be 6 minus 1. R minus 1 is equal to 6 minus 1 equal to 5 ohm. So from on potentiometer, if you see, this will be, let me redraw the circuit. This for the circuit, yeah. And now this resistance is R minus 1. Okay. Now, if we need to calculate VTH, the same thing, VTH is corresponding to R minus 1. So VTH minus R minus 1 divided by E source, which is 4.6 divided by 20. So 4.6 volt is corresponding to 20 ohm wire, isn't it? And VTH is the voltage corresponding to R minus 1, which is equal to 5. So if you solve it, VTH, which will be 4.6 into 5 by 20, 1.15 volt. Yeah, 1.15 volt is VTH. It is pretty straightforward. Okay. Now calculate the resistance. How to calculate RTH? So RTH is nothing but this parallel to this. Actually, we did what last time? This resistance parallel to this resistance. What is called? Let me show. So if you see RTH from here, RTH is nothing but R minus 1 parallel to whole minus R minus 1. So 20 minus R minus 1. Okay, so I think this would be appropriate, because if we are calculating it, we cannot ignore this branch rather than this branch. Okay, so now what we can do, RTH is equal to R minus 1 into, basically R minus 1 is 5 into 20 minus 5 is 15. Okay, so 20 minus 5 is 15 divided by 15 plus 5. So I think 75 by 20, it will be 3.75. Now we will match with this process R minus 1 parallel with R test. So R test was 11. 5 into 11 divided by 11 plus 5, which is 55 by 16. By 16. It is also close to 3.45. Okay. And if you, now the first case what we solved, so at null position, which is nothing but 11 into 6 at null position, divided by 11 plus 6, so 66 divided by 70, so 3.88. Okay, so at null position, so what I'm trying to show here is that equivalent resistance, which Thevenin resistance, which we are calculating at all the different positions. So at null position, it was 3.88. And if you calculate in both ways, this is one way, and other way is R minus 1 parallel with this 20 minus R minus 1. So what I'm trying to imply here, if you calculate with this value and compare with calculation of R minus 1 parallel with R test, both should be equal. But as you are moving your jockey either left or right or different positions from the null position, these values are going to differ from each other. And in that case, it is preferable to take this value of this process. You need to take this. Okay, so that is why a little bit difference will appear in your answer or discrepancy. But if it is different from null position, then it is recommended to use this method. Okay, because this is also parallel here, corresponding to this, because one pointer, one jockey is here, and for this question, we will get R minus 1 is 5 into 15 divided by 15 plus 5. We have already calculated 3.75. Right. So this will be your answer of RTH. Now we need to calculate I test current, and it is point. Yeah, so our test cell voltage was, how much? 1.38, I guess. 1.38 minus VTH, which we have calculated 1.15, and divided by our test, which was 11 plus RTH, is 3. So this value will come out to be positive value. So when we are shifting our potentiometer jockey towards the left hand side, we are observing that this value is positive. How much positive, that I'll let you know by calculating it. 1.38 minus 1.15 1.38 minus 1.15 divided by 14.75. So it is again 15.6 milliampere, but it's in positive. In last question, how much did we get? We got similar value. So it is showing that when if you are shifting from left or right by similar amount, you are going to get similar value of current if your null pointer is placed appropriately, which you might have got it from the lecture. If you want to discuss those concepts, I think we can do that in next lecture. Today, I did not go much in theory of behind these problems. Okay. Laptop. Do you want to discuss theory behind this potentiometer? What are the null positions and all? Or can we do that in next lecture? Let me turn on the light. Okay, next lecture would be fine, right?
Okay, sir.
Okay. Actually, I was going to start, bridges and all, Wheatstone bridges, and I saw in comment that assignment is due tomorrow. So I thought to better discuss this assignment. So you won't face any problem while solving, because the problems we solve those in these assignments, I think they are similar to the due assignment. So that would be helpful. Theory we can discuss in next lecture, or if any assignment, I'll track with when is the next assignment due. Accordingly, I'll prepare theory and numericals for that. Okay, so in the current week assignment, is there any problem based on Kelvin-Varley decade potential divider?
All current.
Sorry?
All current सर्किट नहीं है.
Okay, नहीं है क्या? Kelvin-Varley potential divider. Any question related to? है ना? हाँ. So, have you went through that or like something? And the question is, how much, if the resistance in the first stage of potential divider is 10,000 ohm, then how much should be the value of each resistance in last stage of potential divider towards the output side? So for that, concept we will have to, because it's a bit lengthy topic, so you have to go through the concept. So for this, I think it is better that you go through the lecture in which professor has dealt this topic, because it is a straightforward related to theory of this topic. So if you just see this Kelvin-Varley potential divider topic, that how to how those many lengthy resistances like 10 or 12 or 15 resistances, and how are they connected, and all of them are cascaded, then I think you will get to know that how much will be the value of resistance at the output side. So this topic itself will take half an hour. So it is highly recommendable that you go through this specific part. I don't think it would take you 15 to 20 minutes, and you'll be able to get this answer.
Okay, sir.
Okay. So I think this is all related to current week assignment, right? Anything else is left for this week assignment? I think 4 questions must be there. One related to, energy meter, which is very simple. I discussed initially 2, 3 problems based on energy meter, then based on, electrical circuit consisting AC and DC quantity, you need to calculate angles between them. And the third one related to, test cell and test resistance for deviation from the null position, right? And the last problem is based on Kelvin value, isn't it? This is all, I guess. I'm opening it, so I should be confirmed. Yeah, so here the first question related to the same based on jockey and test cell. So I think that you could easily solve. Yeah, yeah. And second question related to equivalent circuit, and one big potentiometer is given, and one based on meter type. So I think this is all. Just one additional, lengthy potentiometer, in phase potentiometer, and quadrature potentiometer question is there. I think for that you could easily go through the lecture notes or go through the lecture. Couple of questions based on that. Okay, so that's all for today. Okay, Niranjan.
Yes, sir.
So let's wind up, and all the best for the assignment. Thank you very much for joining. Bye. Good night.
Thanks, sir.